In this lecture, we are now going to go over the implementation to the longest common subsequence that we discussed in the previous lecture. So, we're going to start off with the function initialization, longest common subsequence. And remember, we want two strings, so we'll do two string slices. And we want to return a string with our longest common subsequence given to us. So we want to store all the characters into a vector. So for us to do that, we can say let a vector of type char equal a dot chars dot collect. So now we just stored all of our a's into a vector, and we want to do the same for b. And so here we are storing all the characters into the vector. Next, we want to store the links of our vectors. So we can easily create it by saying let length a and length b equal to a dot len and b dot len. So we want to store the links. And then lastly, or not lastly, next we want to say the solution is from within I to j is the length of the LCS. We'll say LCS, longest common subsequence. And then between a of 0 to I minus 1 and b from 0 to j minus 1. So for us to create this solutions vector that we want here, we need to use the links that we generated here. So we want the solution to be a vector, and it's going to contain a vector, and this vector is going to be from 0 to b plus 1, and our other vector will be from 0 to length a plus 1. And I realize that I need to put those there, and let me add that there. Alright, so we just created our solutions vector of lengths of a from 0 to 1, j minus 1, and 0 to j minus 1. Alright, so now we could begin traversing our 2D array from top to bottom. So we want to enumerate all of our possibilities for that. So we will say for I of m of I, so we want two iterators here, and a dot iter, and then remember we want to enumerate, so luckily Rust gives that to us. So we want to enumerate all the possibilities, and then for j and m of j, and we want to do it the same thing for b. So iter dot enumerate. So now we're beginning to traverse down. So if m of I is equal to m of j, there is a new common character. Otherwise, take the best of the two solutions at I minus 1 to j and I to j minus 1. So if m of I is equal to m of j, there's a new common character. Otherwise, take the best of the two solutions at I minus 1 and j and I of j minus 1. So we can very quickly implement this by saying solutions of I plus 1 and j plus 1. So we're just moving our index in the array equals if m of I equals if m of j. So if the solutions are the same, or excuse me, if the characters are the same, then we want to say solutions. I keep saying solutions. Solution I j plus 1. So we are denoting it that we have a common character by putting the 1 value there. Okay, so now we say solution of I, and now we go j plus 1 dot max solution I plus 1 and j. And this max method here that is given to us inside of the vector class is going to compare and return the maximum two values. So we're going to compare I and j plus 1 to solution of I plus 1 and j. So now we just implemented in this portion of it. And so once we've done all that, well, then we have completely enumerated our 2D array from top left to bottom right, or basic what we did in the previous lecture. So now we want to go from the bottom up. So we want to reconstitute the solution string. So we want to get our solution string back from the links. So remember, if the value is 1, then that means we had a common character. And so we want to take that character and add it into our solution string, if you will. So to do this, we'll say let result of a vector of type char equals a new vec, and we'll say let mute I and mute j equals to length a and length b. So while I is greater than 0 and j is greater than 0, we want to traverse from the bottom up. So if if a of I minus 1 is equal to b of j minus 1, then we want to push this result because that means we have a common character. So we will say push a of I minus 1, and now we want to traverse up the array. So we're going to decrement. That way we go back up to the top. Else if solution of I minus 1 and j is greater than solution of I and j minus 1, then we just want to move up the I value. Else, our last case, we just want to move up the j value. So if they match, move up and decrement both of them. If I minus 1 and j, if this index is greater than this index, then we just decrement I, otherwise decrement j. So again, that is just us traversing back up from the bottom to the top of our 2D array. And then, as I said, I always like to reverse my string. That way it's back in kind of the order in which the string was presented to us. And then for us to turn it into our string, we will say result.iter and collect. And I believe that is all we have to do. So let me do a cargo build just to make sure that it runs. It looks like we're missing something. What are we missing? Get rid of that. That way it is actually returned. And line 45, I need to add our semicolon. How about now? Now we're happy. Alright, so let's add in our test cases now to verify that our LCS function works. And we'll add in a couple of test cases to kind of vet it very good. So longest common subsequence. And so we'll have an empty test case. So we will assert equals on our longest common subsequence. So if they pass in 2 empty strings, then we expect an empty one to be returned. And we will do a couple more empty ones where we actually pass in something. We expect nothing to be returned, and if they passed in the first parameter, we would also still expect nothing to be returned. Some more that we can do is we can actually do some simple ones. So we can have A, B, C, D. We expect A to be returned here. A, D, C, B. If we did B, we would expect B to be returned. And lastly, if we did QWERTY, and let's say we passed in RT, then we would expect RTY to be returned. And then let's do a couple more complicated ones. We will say A, B, C, D, GH, and we'll pass in AED, FHR, and in this case we would expect ADH to be returned. And our last test case, we'll do AGGTAB, so that way we have some repeating characters in here, and we'll have GTX, GXTX, AYB, in which case we would expect GTAB to be returned. So let's just double check this to make sure we are returning everything correctly. So we have GTAB, GTAB, so we're looking for ADH, we have ADH, ADH, RTY. So yeah, so everything looks pretty good here. So let's run our test cases and see what we get, and everything is passing successfully. So we successfully implemented in our dynamic programming solution to the longest common subsequence, and hopefully this made sense to you. Again, with it being dynamic programming, sometimes it does add an extra little layer of abstraction, in my opinion, and complexity to it. So if you have any questions about my solution or the algorithm in general, or just dynamic programming in general, please feel free to ask them in the Q&A section. And in the next lecture, we will look at one more dynamic programming solution before we move on to our next data structure.